Hello everyone. So here we have a grade 10 mathematics paper 2 exam. It was written in November 2015. It's 100 marks and you should be able to do this one within 2 hours. Hey guys, so here's all the questions that we're going to be looking at in this question, okay? But I'm going to split the questions up onto different slides just so we have a bit more space to work with, okay? But these are the questions we'll be doing, but I'm going to split them up. So here is the first 3, and then I'll split them up into the next one, and then the last one. Okay, just so it's easier and we have more space. So 19 girls were required to complete a puzzle as quickly as possible. Their time were recorded and they're shown in the table below. Okay, so first question, identify the median time taken by the girls. So always make sure that the data is arranged from smallest to biggest, and thankfully it is. Okay, and so remember, we don't go this way, we're going from the smallest number and then we're just letting the numbers get bigger, and then we carry on over here again. Okay, so the median is the number that is in the middle. So there are a number of ways you could do this. You could, for example, you could count from the back and the front, and you could just keep doing that. I know some learners like to do this, and you just keep going back like that. One from the front, one from the back, one from the front, one from the back, and we should end up, but this is a bit weird, and then here, and then here, and then the number that's left, that will be your median, okay? If you would rather prefer to use a mathematical approach, because remember, the median is the number that's in the middle. That's what median is. The mathematical way is to say n plus 1 over 2. So the way that works is n is the number of people, so or number of things. So 19. So you say 19 plus 1 over 2, which is 10. That's not the answer. That's the position. So we then go to position 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So either way we do it, the answer is 19. Okay, now the next one is lower and upper quarters, okay, or quartiles. So here we can just use the formula. So we can just say for lower quarter, lower, you could say n plus 1 over 4. So that's going to be 19 plus 1 over 4, which is going to give us 20 divided by 4, which is 5. So we go to position 5. 1, 2, 3, 4, and there it is. So that would be 17 as your lower quarter. Then for the upper quarter, you use the same formula, but you multiply it with a 3. Like that. And so, and you know why we're dividing by 4? Because we're looking for quarters. But just now earlier when we were trying to find the median, which is the halfway, then we divided by 2, because that's how you divide something in half. You divide it by 2. That's why we use a 2, and that's why we use a 4. So if you had to do this one, you're going to end up with 15 as your answer. And so we go to position 15. Okay. So we already know that this is position 10, so I'm just going to count from there. 11, 12, 13, 14, and 15 is 22. So the answer here would be 22. So let's say here that the lower quarter was, what did we say, 17, and then the upper quarter was 22. The next question is to draw a box and whisker diagram. Okay, so you must use a ruler for these types of questions. All right, now the way that the box and whisker works is that you need to take the lowest number. Okay, so that's your starting position. So let's say that that's 14. And then your highest position is the 29. So that would be 15 centimeters, because that's going to be 29, right? For 14 plus 15 is 29. Okay, and then what we want to put, okay, so on a box and whisker, you want to put the minimum, you want to put the maximum, which we've done. Then you want to put the lower quarter, which we call that Q1. You want to put the upper quarter, which we call that Q3. And then you want to put the median. And these are all the values that we've already found. So we found the median earlier as 19. So okay, now 19 is 5 from here. So that would be over there. And then 17 would be 3 places from there, so 3 centimeters, so we can go there, so that's 17. And then 22 would be 3 places from this one, so that's 20, 21, 22 over there. There we go. Now the 3 center ones, you put a box around them, like that, and then the 2 on the outside, you just try to connect them, like that. And that's why we call it a box and whisker. So that's the box, and then you've got like your cat whiskers going off to the side. Okay, and that's that for that question. Remember, we're not done. There are more questions. The next one says that the 5-number summary, okay, so the 5-number summary is the box and whisker stuff. So that's the minimum, that's the maximum, then this is Q1, which is your lower quarter, your upper quarter, and then your median. Okay, so that's what the 5-number summary is. It's the 5 numbers that we use when we are on the box and whisker. So the first question says calculate the interquartile range. Now, interquartile range is your upper quarter minus your lower quarter, and so that would be for these boys. It would be the upper quarter, which is 26, and the lower quarter, which is 19. And if you had to work that out, you get 7. If only one boy took 19 seconds to complete the puzzle, what percentage of the boys took at least 19 seconds to complete the puzzle? Okay, wait, what? Oh, okay, so it's not actually too bad. So what we must understand is that if you've got a whole bunch of values, okay, so we've got 19 boys. And if your 5-number summary is 15, 19, 23, 26, and 30, then remember that this is Q1, which stands for, it also stands for 25%. Then this is your median, which also stands for 50%. And then this is Q3, which stands for 75%. Okay. So they say only one boy took 19. So what percentage of the boys took at least 19 seconds to complete the puzzle? So they mean at least 19. So 19 or longer. So like the boys who took 21 seconds, 23 seconds, 24 seconds. They want to know what percentage is that. Well, up to 19, we've covered 25% of the people. So what percentage of the people do we still have on the other side of here? Well, that would still be, we know that there's this, all of this is 100%. Up to quarter 1, that's 25% of the values. So then we still have another 75% of the boys. So you could say here, what percentage of the boys took at least 19 seconds? What they mean by at least is 19 seconds or more. So that would be 75% of the boys. Okay, so for this next question, I just went and wrote down the boys' 5-number summary. So it says, in which group, the girls or the boys? So remember, these are the girls that we looked at in the very beginning. And then the 5-number summary here, these are the boys. So in which group did a larger number of learners complete the puzzle in less than 23 seconds? Justify your answer. So for the girls, we need to go remember what their 5-number summary was. And so if you go back to your free, not your box and whisker, we know that their minimum value was 14. Q1 was 17. The median was 19. Q3 was 22. And their maximum was 29. Okay, so that was the girls' box and whisker. So it says, in which group did a larger number of learners complete the puzzle in less than 23 seconds? Okay, so for the boys, we know that their median value is at 23. So their median is at 23. Okay, so remember the median is the number that divides everything in half. So that means there's 50% of the boys are that way, and 50% of the boys are that way. So for the boys, what percentage of the learners completed it in less than 23 seconds? Well, that would be 50%. So for the boys, we can say 50% completed the puzzle in less than 23 seconds. I think the girls actually did a lot better. Check this out. For the girls, their 23 only comes somewhere over here. I know that's a 22, but even if that was a 20, let's just say that that's around about 23, right? So that means that all of these people in the front were less than 23. So remember that this point over here is your Q3. So that's 75% of the people who have already done up till that point. So that means that if you have to look all the way back, that would be 75% of all of the girls. So for the girls, 75% of them completed the puzzle in less than 23 seconds. Or you could say 22 seconds. So definitely, if there are 75% of the girls completed it in less than 22 seconds, then 23 seconds would be even more. So the girls did way better, okay? Or they completed the puzzle much faster. So we should summarize. So we can say, therefore, the girls completed, or we could say more girls completed the puzzle in less than 23 seconds. So in this question we have, the table below shows information about the number of hours 120 learners spent on their cell phones in the last week. Okay, so let's just try to explain how this table works. So in the last week, there are 10 people, because frequency says how many, so there are 10 people who spent between 0 and 2 hours on their cell phone for the whole week, okay? And then, for example, there are 25 learners who spent somewhere between 8 and 10 hours. Maybe they spent 9.5 hours, maybe they spent 8.5 hours. And then lastly, let's do another one. There are 5 learners who spend somewhere between 10 and 12 hours on their cell phone for that week. And then if you had to go add all of these numbers together, it should give you 120 because there are 120 learners. First question, identify the modal class. Mode means the most, and each of these are called classes. Okay, so we want to find the class that has the most people. Well, that would be the 35. So that class is this one. So you just write down the class like that. Next one, the mean. Okay, so have you already watched the lesson that I've made on how to calculate the mean from a table? If not, just go check that out, and then you'll see that this question's very easy. But if you haven't seen those types of or how to do that, then this question is going to be quite weird. So what we do, it said estimate the mean from the table. So what you do is you take all of the halfway numbers. So for example, the halfway number there is a 1, and then you multiply that with the frequency, and then you say plus, and then you just keep repeating. So 3 times 15 plus 5 times 30 plus 7 times 35 plus 9 times 25 plus 11 times 5. So I just went and added up all of the middle numbers multiplied by the frequency. Okay? And then what you do is you divide all of that by 120. And if we had to go work that all out, we get 6.08 hours. That makes sense. They're saying, remember that the word mean is like the average. So if you look at this class, where do most of the people, where would like most learners be? Okay, so like it's around here, 30, 35, 20. That's a lot of people. So 30 people go between 4 and 6 hours. 35 people are between 6 and 8 hours. And 25 are between 8 and 10 hours. So we should expect that the average learner spends around 6 or 7 hours on their cell phone. And so here we have 6.08. So it makes sense. For this question, these are all the questions that we're going to do. So there's 7 of them, but I'm going to split the questions up onto different slides. But if you want to just have a look at all the questions along, there they are. And then I'll be splitting them up like that and like that. Okay, so onto 2 different pages. So here we go. In the diagram, C is a point on the y-axis, such that A is that, B is that, C is, oh no, they don't give a C, and then D is that. They are a parallelogram. Okay, we might need to know that. So let's just highlight that one. K is the point, that and that, and L is a point such that that is parallel to that. Okay, so everything that they've said is already shown on the diagram. First question, calculate the length of the diagonal dB. Okay, so we need the length formula, which is the same as the distance formula, which is this one over here. So the way it works is you can choose which one is point number 2 and which one's point number 1. I'm going to choose this as point number 1 and this one is point number I just said the wrong thing. This one's point number 2 and this one's point number 1. It doesn't matter though. Like, you can choose it however you want. You will get to the same answer. Okay, so the length of dB is then going to be, so it says that I must take the x value of point number 2, which is a -4, then the x value of point number 1, which is a 4, then the y value of point number 2, and then the y value of point number 1, which is a -4. See, so if there's a -4, I just add it next to that minus. It's okay. And then I just go type all of this on the calculator exactly as we've written it over there. We get a nice answer of 10. And in the test, you must also just show them the formula. Hey? So write down the formula like that, and then in the next step, you would show them the values that you are using. The next question, calculate the coordinates of M, which is the midpoint of dB. Okay, so if we're to connect D to B, there is some random little point, which is the midpoint. Okay, so for that, we would need to use the midpoint formula. Okay, so I don't know why, but this formula sheet was a bit weird, but there's supposed to be an equal sign over there. So the midpoint is equal to that. Okay, so once again, we can just use point number 1, point number 2. And so we could say 4, and then plus -4 over 2, and then -4 plus 2 over 2. Okay, so then we can go work it all out. So you're going to end up here with 0, okay, and then -1. So M is a point somewhere over here, which has coordinates of 0 and -1. The next one says calculate the gradient of AD. Okay, so the gradient of AD. So for that, you use the gradient formula. So we're doing that between A and D. So I'll just call this point number 2 and I'll call this point number 1. And so to work out the gradient, you're going to say the y value of point number 2, which is a 2, and the y value of point number 1, which is a 4, and then the x value of point number 2, and then the x value of point number 1, like that. Go ahead, you can type that all in on the calculator just like that, and you should end up with a half. Now remember, these questions do carry on. Okay, so what we have already calculated in previous questions was that the length of dB was 10. We found that the midpoint of dB was 0 and -1. And we found that the gradient of AD was a half. Now the next one, 3.4, prove that AD, which is this one, is perpendicular to AB. Okay, that's easy. Remember, how do we prove? So how to prove that two lines are perpendicular? You get the gradients of each line. Okay, then you multiply the gradients, and then if the answer is equal to -1, then we can say perpendicular. So if the answer is -1, then they are perpendicular. If it's not -1, then it's not perpendicular. Okay? So we already worked out the gradient of AD in the previous slide. Okay? We said that that gradient was a half. So we now need to get the gradient of AB. Okay? And so there we have the gradient formula over there. Okay, so we're going to do the gradient now of AB, okay? So the gradient, so what we can do is we can say that that's point number 2, for example, and that's point number 1. It doesn't really matter, as I said, you can do the other way around. So what the formula tells us that we need the y value of point number 2, which is a 4, then the y value of point number 1, which is a -4, then the x value of point number 2, and then the x value of point number 1. And if we had to go work that out, we get 8 over -4, which is -2. Okay, so remember what we said. To see if two lines are perpendicular, we work out the gradient of each one, okay? Then we go and multiply them. So let's go multiply a half, which is this one's gradient. Or let's first say here that we are multiplying the gradient of AD multiplied by the gradient of AB. And so that's going to be equal to a half multiplied by -2, which is -1. And so there we have it. Because we get -1, we can say, therefore, AD is perpendicular to AB. So the next question says, give a reason why parallelogram ABCD is a rectangle. So some of you reading that are like, what the hell? Like, it's a parallelogram, dude. Why is it now? How's it also a rectangle? But what we must remember, and they sometimes don't make this very clear in school. Like, I didn't know this when I was in school. But a rectangle, a rhombus, a square. Well, that doesn't really look like a square, but a square. All of these are also parallelograms, okay? But now they're saying, why is the parallelogram a rectangle? So that's a parallelogram, right? But if you make one of these angles 90 degrees, then all of a sudden it looks like that, okay? Then it's a rectangle. So a rectangle is actually a parallelogram with a 90-degree angle, So we've just proved that these two lines over here are perpendicular, so that means that they are forming a right angle. So the reason that it's a rectangle is that it is a parallelogram with an internal angle equal to 90 degrees. So it's a parallelogram with an internal angle equal to 90 degrees. Now some of you might be like, yeah, but Kevin, mustn't we show that all of them are 90 degrees? But guys, remember, it's already a parallelogram. So what do we know about parallelograms? We know that the opposite angles are equal. And we also know that these are parallel lines. So if you had to use co-interior, you would know that this is already 90, and then if you had to use opposite angles again, it's already 90. So you only need one angle to be 90, because the rest will all be 90 as well, because of the properties of a parallelogram. Alright, the next question. Determine the equation of KL. Okay, so here's KL in the form y equals to mx plus c. Okay, so we have y equals to mx plus c. Now, m is the gradient. Now, we have a bit of a problem because you can't get the gradient of KL because we don't know the coordinates of L. However, we do know that this line is parallel to this line, which is parallel to this line. So all three of those lines are parallel. And when lines are parallel, then they have the same gradient. Okay, so that's how we'll get the gradient of KL. So the gradient of KL is going to be equal to the gradient of AD. Why? Because they're parallel. And so, or let's say here that AD is parallel to KL. And so the gradient of KL is a half. So therefore we can say that y is equal to a half x plus c. And so now, to find the point or the point of C, you need to plug in at least 1 point on that line. Now, luckily, we do have the coordinates of K, and so we can plug in the 0 and the -2 1/4 into that equation. So the 2 1/4, the -2 1/4 is the y value. So I'm going to plug that over here. So -2 1/4. By the way, I don't like to work with mixed numbers, so I'm going to convert that into an improper fraction. So that'll be 9/4. So that'll become 9/4 equals to a half, and then x is 0, and then plus c. So if you had to go work out c, you're going to get -9/4. Okay, so then the final answer for that question, let's write it down here. Y equals to a half x minus 9/4. Okay, y equals to a half x minus 9/4. And the last one, write down the coordinates of C. Okay, now this is a nice easy one. The reason is that this shape here is a parallelogram, right? This ABCD. Yes, it's also a rectangle, but because it's a parallelogram, there is a very easy way that we can work out this fourth coordinate. What you do is you look at this point here, and then you look at this point here. Now, how do you go from A to D? So to go from A to D, what do we do to the x values? Well, you minus 4. See that? You go from 0 to minus 4. So you minus 4 on the x. And then what do you do to the y values? You minus 2, because that is how you go from 4 to 2. So you minus 2. So for the x values, we minus 4, and for the y values, we minus 2. So we're going to do the exact same thing to go from B to C. So to go from B to C, we're also going to take the x values and we're going to minus 4, and we're going to take the y values and we're going to minus 2. And so if you're to minus 4 from that x value, you're going to end up with 0. And if you're to minus 2 from that y value, you're going to end up with negative 6. And so the answer will be 0 and negative 6, and the reason is just called inspection. The other way that you could have done that is you could have realized that this is the diagonal. Okay, and earlier on we worked out the length of diagonal BD. Can you remember? It was one of the first questions we did in this question, and we got an answer of 10. Now what we should know is that the diagonals of a rectangle, they are equal in length. So what we can do is we can say that the diagonal, or we can actually just say, sorry, we can say that AC, the length of AC is equal to the length of BD, and that's just because of diagonal of rectangle. Okay, and so that means that the length of AC is 10. So if you just go 10 units down from 0 and 4, then what would you end up with? Well, if you take the 0 will stay as 0 because you're on the you're on the y-axis, so that's not going to change. But the 4, if you take away 10, that becomes minus 6, and so you would end up with 0 and minus 6. But that's exactly what we got using the inspection method earlier. Triangle PQR and triangle SQR are right-angled triangles as shown in the diagram below. Then they give us the length of PR, PQ, QS. So everything that they've told us here is already on the diagram. Okay, so it says refer to the diagram and without using a calculator, write down the value of tan P. Okay, so for all of these triangles, we must remember we need to know what sin, cos, and tan are. So we could use SOHCAHTOA. Maybe your teacher uses a different little riddle. I've seen so many different ones, but I typically use SOHCAHTOA. So what that means is that sin is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. Okay, so if we want to find tan of P, then what we do is we go to angle P, and we're going to use the, so obviously we are in this triangle over here, and we're going to use tan, which is opposite over adjacent. So the opposite side would be the 10, and the adjacent side would be the 24, because the adjacent side is the next to. Some of you might be saying, yeah, but 26 is also next to. Yeah, but that's the hypotenuse. So what we can say is that tan of P would be the opposite over the adjacent, which is 10 over 24, and that would just simplify to 5 over 12. And then sin of SQR. So sin of angle SQR is the next question. So what we do is we need to go find angle Q. Okay, so where's angle Q? So angle Q is over here. Now you got to be careful, like which one are they talking about? So they said SQR. Okay, so SQR. And so they are talking about this little corner angle over here. So that's this angle here. Okay, so we're only working from that angle now, and we're going to use sin. So sin, we know, is opposite over hypotenuse. Okay, so opposite over hypotenuse. And so that's going to end up being sin of angle SQR is going to be opposite over hypotenuse. And so if you had to simplify that, that's going to give you 3 over 5. The next one is cos theta. Okay, so we need to go find theta now. So theta is here, but now be careful. Theta is not the whole angle. theta, if you look at what they told us here, they said PRQ is theta. So we look at PRQ, so P, R, and then Q. So that is theta, okay? And so if that's theta, now we need to find cos of that angle. So we're only working in this red triangle. So cos would be adjacent, because cos is adjacent, and then hypotenuse, which would then be the 26. So we can say cos theta is 10 over 26. And so if you simplify that, that would be 5 over 13. Okay, now the next one is sec. So remember, I haven't actually written those down, but sec is the opposite of cos. So if you look at cos, it's adjacent over hypotenuse. So then sec is hypotenuse over adjacent. Okay, for a little bit of recap for you guys, cosec is the opposite of sin. And so that would be hypotenuse over the opposite. And then cot is the opposite of tan. And so that would be adjacent over the opposite. Okay, and so sec is the opposite of cos, which is hypotenuse over adjacent. So we first need to go see the angle. We're looking at angle SRQ. SRQ. Okay, so R, well, let's first find SRQ. So SR and then Q. Okay, so like that. So SRQ is this entire angle now. So it's not theta, it's that entire angle. So we are working in this triangle over here. And so we're looking for sec. Now sec is hypotenuse over adjacent. So the hypotenuse is 10 and the adjacent is 6. And so we're going to say that the sec of SRQ is going to be 10 over 6, 10 over 6. And if you simplify that on your calculator to 5 over 3. And then the last one, without using a calculator, determine the value of cot over cosec of QRS. Okay, so remember, cot is the opposite of tan. And so instead of saying opposite over adjacent, you'd say adjacent over opposite. And then cosec is the opposite of sin. And so instead of saying opposite over hypotenuse, you're going to say hypotenuse over opposite. And so if you had to go to theta, remember theta is this little part here inside this triangle. So let's go work out what the cot of that would be. So cot of theta. So cot is adjacent. Okay, so the adjacent will be 10. And the opposite would be the 24. Okay, so that's 10 over 24. If you simplify that, that is 5 over 12. Okay, so we've got that part. Now they want us to find cosec of angle QRS. So QRS is that. Okay, so it's this whole angle. So that means we're working in this triangle. So if you want to find cosec of QRS, well, we know that cosec is hypotenuse over the opposite. So hypotenuse is the 10, and then the opposite is the 8. And so if you had to simplify that, that would be 5 over 4. Okay, so now we can put everything together. So we can say cot theta over cosec of QRS. And that's going to give us 5 over 12 divided by 5 over 4. And so that's the same as 5 over 12 multiplied by 4 over 5. Because that's what you can do when you're dividing two fractions. And this should eventually give us 1 over 3 after you plug that all in on your calculator. In the diagram below, P is a point in the third quadrant. Then they give us this angle beta, and they tell us the following. Okay, so for 4 marks, write down the values of x, y, and r. So what we're going to do is we're going to take this equation, and we're just going to try to get the cos b by itself. Okay, so you could do that by first taking the 15 over to the other side, like that. Then you can divide by, oh, I don't know why I have 2 c's there. You can then divide by 17, and there we have it. So cos is equal to negative 15 over 17. So from SOHCAHTOA, maybe your teacher uses a different one. Maybe, like we need to know what sin, cos, and tan are. So we know that cos is adjacent over hypotenuse. Some learners prefer to say x over r when they work on a cast diagram, which is fine. So what we're going to do is we're going to complete the triangle. Remember, we never make a triangle that goes that way. It always goes vertical line to the x-axis like that. And then we're going to use this as our little angle. And we're going to say adjacent and hypotenuse, or x and r. And we're going to use the 15 and the 17 to help us. So remember, cos is the adjacent, or if you want, you can say x. So they're telling us there that the x is negative 15. Okay, so we can put a negative 15 over there because that's the x. And then they're telling us here that the radius is 17. So the radius is 17, like that. Then what we can do is we can use Pythagoras to try find this one over here. So by using Pythagoras, you would say 17 squared minus 15 squared. Because remember, this is not the longest side. So you would have to minus them like that. Okay? And if you work that out, and then we need to take the square root because of Pythagoras. And we get a nice answer of 8. So this will be 8, but we'll say minus 8 because as you can see, this y value is going down. Okay? So it's a negative y value. And so there we've gotten all the values now, which is awesome. So now we can go answer their question and we can tell them what x, y, and r would be. So x is negative 15. Y is negative 8. And then r is 17. Okay. Now, without using a calculator, determine the value of sin. So what we do now is we go back to this little triangle and we go find sin. Now, we know that sin is opposite over hypotenuse, but you can also use y over r. So if you look at the opposite, it's minus 8. If you look at the hypotenuse, it's 17. So that means that the sin of beta is opposite over 17, and so that's like that. The next question asks us to find cos squared 30 multiplied by tan beta. Okay, so tan beta we can definitely get from this diagram, but what about the 30? Well, remember, special triangles. Let's quickly draw out the special triangles. So we know that you get a 30, 60, 90 special triangle. 1, 2, square root 3. This you just need to know, okay? And then there's another special triangle, which I'll just put down. I don't think we're going to use it, but let's just write it down anyways. So we know that that's a 45, 45, and so this would be 1, 1, square root 2. So that's where we're going to get the 30 from. Okay, so what we're going to go do is go find cos 30. Now remember, cos is adjacent over hypotenuse, which is the same as x over r. So for cos 30, you're going to look at the adjacent over the hypotenuse, and so that's going to be the square root of 3 over 2. Okay, and then you're going to square that because that's got a square. And then you're going to go find the tan of beta. Now remember, tan is opposite over adjacent, or y over x. And so if you had to work out the tan of beta on this triangle now, you would get opposite, which is minus 8, over adjacent, which is negative 15. So we'd say negative 8 over negative 15. And so now we're just going to go simplify a little bit. So you could type this on your calculator, so it makes the teacher think that you worked it out. And that should give you 3 over 4. Just don't go type in all of this in the calculator in one step, because then it looks a bit suspicious. So 3 over 4. And then these two negatives should cancel out. So that's 8 over 15. And then you can go multiply these two things together. And so that's going to give 2 over 5. Okay, so that's what the answer should be for that one. 2 over 5. For this last question, they want us to calculate ROP. Now, you got to be careful. ROP could go that way. That's ROP. But that's also ROP going that way. So which one is it? Well, they say here, ROP is B. So they want us to calculate this whole angle over here. So we already know that this part up to here is 180 because that's just a straight line. So what we need to go find now is just this little piece over here. Okay, just this little piece over here. So we already know from like previous questions that sin of B, for example, is 8 over 17 or negative 8 over 17. So sin of B is negative 8 over 17. So to get the angle B, you're just going to say B equals to shift sin, and then don't put the negative on your calculator, just leave it as a positive. And so you could go then say shift sin of 8 over 17, and that's going to give you 28.07 degrees. So that would be this angle over here. Okay, and so now if we wanted to work out this whole angle, we could just say that that whole angle, the whole of beta, I know it's a bit weird that we're saying beta is 28.07 and now we're saying beta again, but yeah, so we're going to say beta, that whole, we're going to rather say angle ROP, there we go, equals to 180 plus 28.07, and that's going to give us 208.07 degrees. Okay? In each of the following questions, solve for x over the interval x between 0 and 90. Give your answer correct to 2 decimal places. Okay, so this is just like solving for these are like trigonometric equations. So if you haven't watched or if you haven't done trigonometric equations, just go watch the videos that I have on trig equations. Okay, so here this is a nice easy one, 5.2.1. Because they already have everything pretty standard. So to get x, you're just going to say shift tan of 2,22, 2,22. And so if you work out x, you're just going to end up getting 65.75 degrees. For the next one, you're just going to do the same thing. So you're just going to say, okay, but now the problem is we don't have sec on our calculator. So what we're going to do is we should remember that sec is the opposite of cos. So we know that sec is equal to 1 over cos and cos is equal to 1 over sec. So what I'm going to do is I'm going to say sec x plus 10. Okay, I'm just writing down the equation so long, 759. So then we can say cos x plus 10 equals to 1 over 5.759. Okay, and so now we are in a good position. Don't worry about this part right now. Or you can just say x plus 10, and then you're just going to say shift cos of 1 over 5.759. So we're going to say x plus 10 equals, now go work out shift cos of that. Oh, and it gives us a beautiful 80 degrees. And so then if you had to get x by itself, you just say 80 minus 10, which is 70. Okay, so the answer for that one is 70 degrees. Okay, for the next one, you want to try get this sin x by itself. You want to try get that sin x by itself. So what you do is you take this minus 2 over to the other side first of all. So it will be 1,24 plus 2. Oh, sorry, we still have the over 0.2. And so that's going to give us sin x equals to 3,24. But we still have 0.2 over here. I keep forgetting about that. Now, to get this 0.2 to the other side, you're going to multiply it on the other side. So you're going to end up with 3,24 multiplied by 0.2. And so you're going to end up with sin x equals to 0,648. And so now to get x by itself, you're just going to say shift sin of 0,648, and so x is going to be 40,39 degrees. In the diagram below, the graph of f of x equals to negative 2 cos x is drawn. Okay, so this is a graph of negative 2 cos x. Now, the first question says write down the amplitude. So the amplitude is the, so let's quickly write down what that is. The amplitude is the distance, or let's say vertical distance, from the center to the top, or if you want, you could even say to the bottom. So what do I mean? Well, the first thing is to find the center. So in this scenario, the center would be over there. But if the graph has moved up or down, then the center would also have moved a little bit up or down. But in this case, it's over there. Now we look at the distance from that to the top. So you could go like that, or you could measure that distance over there. But the point is that whatever you measure, the distance will be 2. Because it's going from a y value of 0 to a y value of 2, and so the amplitude is 2. Never put a negative for amplitude. Next question, write down the minimum value of f of x, which is this graph over here. Okay, so let's go write down the minimum of that one so long. The minimum is the lowest point, so that would be minus 2, right? Now, so it's minus 2. Then you add 3. So we're going to add 3 to that. So it's minus 2, but then we must add 3, and so that would be 1. On the same system, draw the graph of sin x plus 1. Okay. So for this one, we can actually just use our calculator. Let me show you. Step 1, put your calculator into table mode. So for you, that might be option number 3, or just have a look at that. Now, f of x. So don't go write down the f of x that we have at the top here, minus 2 cos x. We just want to look at the graph that we are drawing. So the graph that we are drawing is sin x plus 1. So we say sin, then we say alpha x, close the bracket, plus 1. That's what we're drawing, okay? G of x, we don't have another graph. So don't get confused with the f of x and the g of x on the question. What the calculator is trying to ask you is, what is the equation of the first graph that you want to draw, and what is the equation of the second graph? We aren't going to do a second graph, so we just skip this one by saying equal. The starting position is, where are we starting on the graph? It's at 0 degrees, so we're starting at 0 degrees. The ending position is going to be where we end, which is 360 degrees, because they asked us to draw it between 0 and 360. And then the step. So for a sin graph and a cos graph in grade 10, we just use 90 degrees for the step. If it was a tan graph, you could use 45 degrees. Okay, so sin graph, cos graph in grade 10, we just use 90 for the step, and there we go. So here we have all the values, so I'm going to quickly write those down on a piece of paper. Okay, so if you follow with your calculator now, the first point is when x is 0 and y is 1, so that would be over here. The second one was when x is 90 and y is 2, so that would be over here. Then 180 and 1, and then 270 and 0, and then 360 and, 360 and 1, so that would be there. And now we just try to draw a nice, neat sketch graph through that. There we go. So that's what our graph would look like over there. The next question, use the graph to determine the following, the value of f180 minus g180. So what does that mean? It means if we go to 180 degrees on the graph of f, which is this one, so we go to 180, and then you go read off the value. So it means you must go read off the value, which is over here. Okay, so it's a 2. So it's a 2, okay? So we put a little 2 over there. And then we say minus. And now they want us to find the value of G180. So if you go to G180 on the graph on the red one, there it is. So it's a 1. So you say 2 minus 1. And so that would be equal to, come on, I can't write an equal sign. That would be equal to 1. Okay, so that's the answer for that. And then the last one, for which values of x will f of x times g of x be a positive? Now, I know a lot of students don't like these questions, but I'll show you what you can do. So what you have is f of x, and then g of x, and then make a little table like this, and then do this. Okay, now, think about this carefully. They want you to multiply f of x and g of x, and they want the answer to be bigger than 0. So they want the answer to be positive. How can you get a positive when you multiply two numbers together? You can either have this one as a positive and this one as a positive, because when you multiply two positives, you get a positive. Or you can get a negative and a negative multiplied together. Okay, so what we are going to go do now, and we can call this scenario, well, let's say this is number 1, and this is number 2. So what we're going to do is we're going to look at scenario 1. So we want to go see, are there any places on the graph where both of them are positive? And they're talking about the y values. So this area here is not going to work because this graph is negative. You can see it's got negative y values, but this one is positive. So that's not what we want right now. We want both of them to be positive. So that would be that area over there. Because in that area, both of the graphs have positive y values. Can you see that? And then as soon as you go past this point, this graph becomes negative. And as soon as you go this way, this graph becomes negative. So that is where they are both positive. So we could say, so let's write the answer over here. We could say x is bigger than 90. We're not going to include the 90 because they don't want us to include the 0. Or like include where they... Well, what I'm trying to say is they didn't put a bigger than and equal to sign. Okay, so we're going to say from 90 up to 270. If you prefer to use interval notation, you could say x is an element from, whoa, Kevin, from 90 up to 270, like that. Okay, now we need to go look at the second scenario where both of the graphs are negative. So there isn't actually a place on this graph where they're both negative at the same time. I mean, this graph's negative here, but then this graph's positive. And this graph's negative here, but then this graph's still positive. So there is no place where they are both negative, so we don't have to find any answers in that interval. And so the only answer would be that over there. And then lastly, the graph of f is reflected about the x-axis. Okay, so let's just think about that before we move on. So that they're saying that this graph here is going to be reflected across the x-axis. So that means that this little point is going to end up going over here. So it's going to go there. This point will stay there because it's already on the 0. This point over here will end up going down here. And then this point over here will end up going over here. And so, okay, so if you had to draw that, they're not telling us to draw it. I'm just trying to get us to see what would happen. And then they say it is now moved 3 units down. So what that now means is that each of these points is now going to go 3 places down. Okay, so all of those points are going to go 3 units down. Okay. So the next question says, well, the first question says, okay, now determine the equation of h. Okay, so h, we know that it is this graph, but it's flipped over. So that means that this negative would now turn into a positive, okay, because it's the flipped over version. And then they move it 3 units down. So we say minus 3. So that's for 6.5.1. Let's say here 2 cos x minus 3. Or let's write it out properly, Kev. H of x equals to 2 cos x minus 3. The next one, the range. Okay, so the range is just the y values. So the highest y value and the lowest y value. So the highest y value will be this one, but we still need to move it down. So it would end up going down here to minus 1. Okay, so let's actually show you what it would look like. This one would go all the way down to minus 5. As I said, we don't have to draw it. I'm just showing you guys something. And then this point here, which is at 0, would go down to minus 3. And then this one would also. And then this one here would go down to minus 1. So the graph would do something like that. So the range would go from so the highest value is minus 1 and the lowest value is minus 5. So with range, we always start with the lowest number. So you could say, now I'll show you 2 different options. You could say y is an element. Going from minus 5. We do include these numbers now because the graph does touch those. Okay, so that's how some students write it. But then there are other students who would prefer to use this method. To say y is bigger than or equal to minus 5, but then smaller than or equal to negative 1. So here is the question that we are going to do, but I'm going to split the questions up onto separate slides just so that we have a bit more space. Okay, so here's the questions, but I'm going to split it up onto 7.1, 7.2, and then 7.3. So it says that a concrete gate post comprises of a right rectangular prism. Okay, so that's the rectangular prism, and then it's with a square base, and then it's got a pyramid on the top. Okay, so it's just a rectangle, like a box, right? It's like a box, and then on the top we have a pyramid. Okay, that's all that the shape actually is. And then the length of the sides, okay, so they've told us all of that, blah, 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 blah. And then it says the perpendicular height of the pyramid is 8. Okay, now these formulas, by the way, I didn't give these formulas. The person who set up the exam gave you the formulas, all right? So it says the first question, calculate the volume of concrete required to make one post. Okay, so obviously we're going to put some concrete in the rectangular part, and we're going to put concrete in the pyramid part. So we are literally just going to work out the total volume, you're just going to say it's the volume of the rectangular prism. Think about it. You're just going to put concrete inside there, and then you're just going to add the amount of concrete that you can put in the pyramid. Volume is very easy. It only gets a bit weird with surface area. That's where you got to start being like a bit careful and stuff like that. Okay. So they don't give us the formula for the rectangular prism, but you should remember that for a rectangular prism, it's just length times breadth times height. Okay. So if we had to go work out this volume now, it's going to be 30 multiplied by 30 multiplied by 150. You see I said the length, the breadth, the height. And then we're going to say plus. Now we need to do the pyramid. So the volume of a pyramid is given to us over here, where they say that it's a third, and then they say it's the area of the base. So the base of a pyramid is this part here. So what is that? It's a square. So you just need to know what the area of that square is. Well, we know that this is 30 and this is 30, so that square would be 30 times 30. And then the height of the pyramid. Now some students get confused, like what is the height of a pyramid? So if I draw the pyramid from the side, okay, no, that's not going to work, Kevin. So is it the part that goes up along the side like that, or is it from the middle straight down to the bottom? Yes, it's the one that goes from the top down to the bottom when we are looking at volume like that. So they've given us that, thankfully. They said that that's the perpendicular height, so that's just 8. And there we go. Can't get easier than that. We go ahead now, we go calculate all of this, and we end up getting 137,400, and then it would be centimeters, but because it's volume, we'll say cubed, not square, but cubed. Now it says calculate the surface area of the pyramid section of the post. Now, you got to be careful when they give you these random formulas. Okay? What they are saying is that if you had a normal pyramid, okay, so let me try to draw a pyramid. Okay, now if you had to try to find the area of that pyramid, well, what would you have? You would have 4 triangles. Can you see the 4 triangles? And then what else would you have? You would have a square or a rectangle, whatever they tell you, at the bottom. Okay, and so that's what they're trying to say here. They say that it's the area of the base, which would be this one. And then they say that it's, okay, then they add this weird stuff. I don't really like to use these formulas, but I guess we will because they've given it to us. But this part here is the triangles. Okay. Now, that's the formula for a normal pyramid, but this is not a normal pyramid. Why? This pyramid is attached to the top of a rectangular prism. So which of these parts would we not see? Well done if you realize we're not going to see the bottom. We're not going to see that. So we're not going to use this part of the formula. Remember, this formula is for a normal pyramid that is standing by itself, not a pyramid that is attached to another shape. And that is where students get it completely wrong. Okay, so we'll just use this formula. As much as I don't like to use these generalized formulas, we'll use it anyways. So it says that the area of that pyramid is a half, and then we need the perimeter of the base. Well, that's easy. The base is this part, and the perimeter would just be 30, 30, 30, 30. So perimeter, you just add all of that together. So that's just going to be 4 times 30, because there's 30 plus 30 plus 30 plus 30. And then we need the slanted height. Oh, so we need the slanted height now. Now, what is that? Well, now this is the height that goes along the side. Okay, so let me show you how we do this. We know that we've got this pyramid if we look at it from the side like that. We know that the vertical height going straight down the middle is 8. Right? That's this one. We know that this length is 30. So what we do to find because what we're trying to do now is we are trying to find the slant height, which is this one here. Okay. So what we do is we divide this number in half. So we say 15, and that would be this piece here. Bam, bam. 15, okay? Then what we do is we use Pythagoras because this is 90 degrees, and that's how we find this length. So we say that the slanted height, slanted, is equal to, now we just need to use Pythagoras, so we're going to say 8 squared plus 15 squared, and then obviously we take the square root of that, and then sometimes we should just give a reason and say Pythagoras, and we get 17. Okay, so now we can just go fill that in as our slant height over there, and then we work it out. And we get 1,020, but now this is now area, so we say centimeters to the power of 2. The last question says, if the length of the sides of the base is halved. Okay, so if the length of the sides of the base, okay, so the base is this part, right? So what they're going to do is they're going to change each of those to 15. So we're going to end up getting a much smaller little pyramid. So the base is now 15. Okay, the height is still the same, so I don't know why I drew that so small. Let's actually make the height the same. So everything's the same there, and then this height is also the same, so that's still going to be 8. Okay, so that's all the same. We've just made it a lot more narrow because each of these is now 15. But the height is still 150, and that's still 8. At the length of the side, how many posts having the same design can be made with the same volume of concrete as the original post? How many posts having the same design can be made with the same volume of concrete? Okay, so they pretty much, the volume that we got for this shape earlier, so the volume of original was 137,400. So let's quickly go work out the volume of this one. So the new volume, so that's just for because remember we said that the volume calculation was very easy. It was just the rectangular prism, and then plus the pyramid. Okay, and with volume, it's straightforward. Like, it's only with surface area, like I said, that things get weird. So for the rectangular prism, we said that it was the length times the base times the height. So that's going to be 15 times 15 times 150. Okay, plus, and then the pyramid was a third, and then area of base, which was the square, so that was 15 times 15, and then the height is still 8. Okay, so if we go work this out, we end up with 34,350. Okay, so then we're just going to divide these two numbers together, because they just want to know how many of these can we make until the volume will be the same as this one. So we can just say 137,400 divided by 34,350, and we get 4. So we could make 4 posts. In the diagram, ABCD is a rhombus. Okay, so now you must make sure you know your rhombus properties. If not, let's do a quick crash course. So with a rhombus, all the sides are the same. Okay, same length. These two are parallel, and these two are parallel to each other. If we look at the diagonals, they do not have the same length. But from a rhombus, we must remember that they do intersect at 90 degrees. We must also remember that these two angles are the same, and these two angles are the same, and then these two are the same, and these two are the same. All right, and then they go give us all the other information, so that's fantastic. Oh, and then yes, sorry, this length is the same as, oh, I don't have to put 3 lines, I can just put 2 lines. This length is the same as this length, but then this length is the same as that length. All right, so the first question, write down the sizes of the following angles. Angle CDO, so where's CDO? CDO. Okay, well, we already just said that this angle and this angle is the same, right? That's what I showed you here. That's a property of a rhombus. So we can just say 36.87 degrees. Thank you very much. Angle AOD. AOD. Well, we just showed you here that the angles of a rhombus are all 90 degrees at the center. See, like if you know your properties, these questions are very easy. But if you don't, it's like, life could be better right now. Okay, now the next one, calculate the length of AO. Now, this is interesting. So we only know this, and we only know this, and they want us to find AO. So you can't use Pythagoras because you don't have 2 sides. For Pythagoras, you need at least 2 sides. But if we have one side, but we also have an angle, did someone just say trigonometry? We can use trigonometry. So you know, like when we use like SOHCAHTOA, maybe your teacher uses a different one, but we need to know that sin is opposite over hypotenuse, cos is adjacent over hypotenuse. So however you remember this, this is what we're going to use now. We are allowed to use this because this is a 90-degree triangle, because we know that this is 90. Okay, so we're going to start at this angle, and we're looking for this one, which is the opposite. And what do we already have? Well, we already have this one, which is the adjacent. So we're going to look for opposite, and we have adjacent. So opposite and adjacent, we'll use tan. So we'll say tan, and if you're a bit funky with your trigonometry and it's not going so well, just go practice some of the trigonometry videos that I've made, where we talk about how to use sin, cos, and tan to find the lengths of sides in a triangle and all of that good stuff. Okay, so what we'll do is we say tan of the angle that we have, which is 36.87, equals, now we say opposite, which is AO, over the adjacent, which is 8. And now what we do, some students struggle with this, we've got to try to get this part by itself. So what we do is we take this 8 and we multiply it over to the front of there. So we end up getting 8 tan 36.87 equals to AO. Oh, we get a beautiful answer of 6. So we can just say 6 centimeters. Okay, fantastic, guys. So that's 6 centimeters. By the way, this is 8 centimeters because we know that with a rhombus, these two are the same. Or maybe we shouldn't say that right now. We'd probably have to give a reason for that if we have to use it. Okay, so we've got that. Fantastic. Now it says if E is a point on AB, so it's somewhere here, such that OE is parallel to DA. Oh, okay, so here's DA. And then OE, so OE would be there. Okay, so E would be here. Because these lines are parallel. See that? They've got to be like railway lines. Calculate the length of OE. Okay, so they want the length of OE. All right, did someone just say midpoint theorem? So remember, if you want to use the midpoint theorem, then you need one of the 2 scenarios. You either need to know that this and this is the same, and this is the same. Then, from that, you could say that these 2 lines are parallel, and you could also say that this one is half of this one's length. That's the one scenario. In the second scenario, they will tell you that these lines are parallel, and then they'll give you one of these, and then what you can go and say is that this side must be the same as this side. Wait, maybe I should do that in green. So you could then say this side is the same as this side, and then you could also say that this is half of that. So, if we look in this triangle here, let's see what we have. So we know that this side is parallel to that side. Okay, they told us that. They did tell us that. That's great. Now, we know that this length and this length is the same, because remember we said it here. So we should just go tell them that so long. So that would be our first thing that we can say. We can say that OB is the same as OD. Now we must give a reason. So we could say diags of a rhombus. Let's write that a bit better. Okay, so we know that this is 8. And so there we have it, guys. We know now that we've got the midpoint over here because these two are the same. So that's fantastic. And we know that these are parallel. Bam, bam. So, all right, so because these two are now the same, like we said, and because we've got the parallel lines, we know that the midpoint theorem will work. So what we need to, and that means that this length, which is the one that we are trying to find, will be, this length here would be exactly half of this length here. So now we just need to quickly go find this one. And that'll be easy to do because we can just work in this triangle because we know now that this is 6. And so we could just use Pythagoras, or you could use trigonometry again if you wanted to find the length of AD. So we could say that AD is equal to the square root. So I'm just doing Pythagoras right now. So I'm saying 8 squared plus 6 squared. And then I must say Pythagoras. And so if you had to go work out AD, you're going to get 10. So AD is 10. And so now if we return back to that original triangle we were working in, and so now we can say that EO must be half of that one. So we can say EO must be half of AD. And let's give a reason for that. Okay, so I've run out of space. But you would say converse. I'll explain now why we say converse. Converse midpoint theorem. Okay, so why did we say converse? Well, if we have, okay, so we have two scenarios. If we have the midpoints, okay, so if we have this, and we know that this side is the same as this side, and this side is the same as that side. So that's if we've got both the midpoints. Then we can say lines are parallel. So let's rather say here. Okay, so in this one we were given the midpoints. See that? We were given both midpoints. Both midpoints. So then from that we can say that BD is parallel to CE and BD is half of CE. Okay? And this one you just say midpoint theorem. That's the normal way around. But sometimes we have it the other way around. So they give us one midpoint and then they give us the parallel lines. So we are given one midpoint plus parallel lines. And then from this we can say that AD is equal to DE. So AD is equal to DE. And then we can also say that BD is half of CE. When it's this way around, then we say converse midpoint theorem. And so we can finally say EO is half of 10, which is 5 centimeters. In the diagram below, D is the midpoint of side AB. Okay, so D is the midpoint, and they've showed it that these two are the same, so it is the midpoint. What else? E is the midpoint of AC. Okay, so we've got a midpoint over there. Fantastic. DE is produced such that DE is equal to EF. Okay, so they've showed us everything on the diagram, and those lines are parallel. CF and BA. Yes, but they've showed us that. Okay, so it says write down a reason why triangle ADE is congruent, that's the 3 lines over there, to triangle CFE. Now, we don't have to go prove it. It's only for 1 mark. We just have to tell them. So it's either going to be like side, 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 angle, side, side angle angle, or RHS. Okay, so those are the 4 congruency things that we've looked at. So it says write down a reason why triangle ADE is congruent to CFE. So CFE. Okay, so it's that one. Oh, okay, so that's a nice one. Why? Because, well, we know that this side and this side are the same, so that's a side, or just a side. That's another side, those two are the same, so that's side. And then we've got angles, which are vertically opposite. So it's side, angle, side. So we'll say side, angle, side. You don't have to go prove it. It's only for 1 mark. They didn't say prove that they are. They just said explain why, or write down a reason. The next one, write down a reason why DBCF, they want to know why is that a parallelogram. Cool, we know that something is a parallelogram if there are 5 different reasons. So opposite sides parallel, that's one reason. Another one is opposite sides are equal. The next one is diagonals bisect. The next one is opposite angles are equal. And then the last one is opposite or one pair. Sorry, this should have said both pairs. Both pair. This should say both pair. Let's say both. Let's write it a bit better. Both pairs. This would say both pairs. And then this one is one pair of sides equal and parallel. Okay, so let's see what we have here. Now, we've just proved that these 2 triangles, this one and this one, are congruent. Remember, congruent means exactly the same. So it means then that this side and this side are the same, so we can make them equal. Okay, so now if we return back to our parallelogram, if we look at these 2 sides, we can see that they are equal in length, but they both have the 2 lines over there, but they are also parallel. So it would be this one down here, one pair of sides equal and parallel. So we can say one pair of sides equal and parallel. Okay, and then the last one. Hence, prove the theorem which states that DE is equal to a half of BC. So what we know is that this length is the same as, DF, right, is the same as BC. So DF is the same as BC. Why? Because it's a parallelogram. So we can say op sides of a. Now you can say parallelogram like that, or I've seen some schools do it like that, but I'm just going to go opposite sides of a parallelogram. Okay, so we know that, right? But then we also know that these 2 are the same. So we can say that the length of DE is a half of the length of DF. Okay? But now we know that DF and BC are the same. So we can also just say that DE would then also just have to be a half of BC. And that's exactly what they were trying to show us, or asking us to prove over there.